Lesson 92, the dreaded boat in the river problems. Because everybody runs into the problem of trying to figure out how long it's going to take to go up the river or down the river, because you all know the speed of all the rivers that you're in and how fast your boat goes, so you can tell your mom, well, Mom, the river's going 8 miles an hour, my boat will take me 23 miles an hour, figure all that out, I'll be home in 2 hours and 14 minutes, so plan on dinner then. So then if you're not there in 2 hours and 14 minutes, you can send out the Coast Guard looking for you, and then you'll be saved.
Find out you're seriously spending a lesson on this.
Yes, we are spending a lesson on this. Okay. So, we have a boat in the river. That boat has a speed of 10 miles an hour. Okay? So, focus here on me. We're going mile an hour, we're not going to do knots.
That sounds like one of those, like a figurative problem, like we have a boat in the river, like we have an issue kind of thing.
We have a boat in the river, yes. That's kind of like secret talk over the radio, so.
The Eagles, yeah.
It's like, what is that movie out about Olympus? Olympus is falling, yeah, kind of that whole, we have a boat in the river, Olympus is falling, yeah. Yeah. Okay. In Elf, what does he say? Santa's got a brand new groove or something like that?
What?
That big, chubby black guy that's in charge of the store, he says that when he comes in and somebody has come in and redecorated the whole area.
Oh.
You know, that whole part. Yeah, it's quit humoring me. I know you have no idea.
No, I know what you're talking about. I seriously do.
Okay.
He's like, someone's trying to make us look good and blah, blah, blah.
Yeah, that's it. Okay, boat in the river.
Yeah,
So, Riley's got his boat, and it's a sea kayak, 17 foot long, 37 pounds, Kevlar. He just bought it. Puts it in the river. He is able to paddle at 6 miles an hour. Okay? He's a speedy paddler. All right, so he gets in the Kenai River, and the Kenai River is traveling or moving along at 10 miles an hour. So he decides to go downriver, obviously, because it's a lot more fun to go downriver than upriver. All right, so the river's pushing at 10 miles an hour. He paddles at 6 miles an hour. How fast can he go down that river?
16 miles.
16 miles an hour. He turns around to go home. How fast can he go up the river?
Negative miles per hour. He can't.
He can't go home. He will be going -4 miles per hour. But you get the idea. Okay, so if he's going downriver, he's adding his speed to the river speed. If he's going upriver, he's taking away.
No, the river speed is taking away
Yeah.
from his speed.
Yeah, the river speed is taken away from his speed. So, boat plus the water for going downriver, boat minus the speed of the water if he's going upstream. Okay, which gives us some things that you need to put in your notes. Downstream rate. We will call that boat plus water. Upstream. Upstream will be B minus water. Yeah, by the way, or by. Okay. What is the definition for distance using rate and time? B equals rate times time. Okay? So, when we're talking about going downstream, we'll call this our downstream equation. Downstream equation says that our distance downstream equals our rate, which is going to be what? B plus W, because we're talking downstream, times what? Time downstream. Because if you're going downstream, you may go faster than when you're trying to go upstream. Okay? Upstream equation. And these are both really good equations to have. We've got our du, our distance upstream, and we're going to say that is equal to b minus w, again our rate upstream, times our time upstream. Okay? So, when you're given these kind of problems, we've got a few steps here and you're good. They're not really very difficult at all, I don't think. Okay, you got all that? Can I erase it?
No.
Yeah.
Well, I need the. Where are these gridded?
Oh, I don't know. Everybody always talks in math that the worst part of algebra are the boat in the river problems
No.
or the train problems. If a train starts here and there's another train that starts there.
Didn't we already do those?
Yeah, we did. So you've graduated into boat in the river
These
problems.
just seem like the same.
Yeah, they kind of are. They're not too bad.
In physics, that works because you have the boat moving sideways, and the stream going this way, and you have to figure out how far down.
Yeah. Yeah, if any of you are ever interested in getting your operator of uninspected passenger vessel license, like what
I was gonna do that.
Kendra's dad has in order to guide on the Kenai, I have one in order to captain halibut charters. I think it's good for 50 miles offshore, where I can, well, where I
You
have
just wanted to
captain.
say R.
Yeah, where I've captained halibut boats and stuff. One of the things in order to get your license is you have to go and take a test, and they're saying the wind's blowing from this way, the current is pushing you this way, and your boat is going this way, but you want to go that way. How long is it going to take you, and what compass setting do you have to use in order to get to where you're going?
Straight ahead.
Which-
Everyone paddle on.
In some respects, it's a good thing to know. In others, you just say, I'm heading that way. It doesn't matter what compass setting I've got, because see that light? All I have to do is end up there, you know. But when you're out in the middle of the ocean and you can't see land, sometimes it's good to have that. Or you just put things into your iPhone GPS and it tells you everything. You don't have to do anything else.
Wi-Fi and put it in the-
No, but you have a data plan.
G.
Okay. So let's do one.
If you spend the money on a data plan, though, you don't have enough money left over for a boat.
That is true. Yeah, it's about, you can pretty much buy a boat with the data plan cost.
This is a-
Okay, so Tim and Caleb over here decide to do a river journey. It takes them the same amount of time to go 60 miles downstream as it does for them to go 20 miles upstream.
Oh, I thought
Okay.
it was gonna be like, this is how fast the river is, this is how fast the paddle.
Oh,
They're
we'll
going
get
20
there.
miles, how long will it take?
So the time downstream and the time upstream are the same. It's just when he goes downstream, they're going 60 miles, but to go upstream, they can only get 20 miles in that time, okay? So the time upstream's a lot slower. So if you look at example 92.1 on page 383, that's the example we're doing. All right, so we are talking upstream and downstream, so we're going to use both of the equations that I had there on the board. I'm going to use this equation, and I'm going to use the, b minus w. And you will use these equations for every problem that you do, for these boat in the river problems. Okay? So, one of the things that's nice is our times are the same. So really, you don't even need this u here on this time or the d on that time. It doesn't really matter because the times are the same, so it won't be a problem. So we'll just call them time. You can leave the TD and TU if you want, but it doesn't really matter.
I don't know what that means.
All right, so let's put some information down. In the equation, let's see what it gives us. So, Tim and Caleb can go 60 miles downstream. Is that 60 time, rate, or distance?
Rate.
Distance.
Miles, distance.
And is it upstream or downstream?
Down.
Okay, so we're gonna substitute this with a 60. Okay? It's nice to put numbers in. All right, let's see what else we've got. Took them the same time to go 20 miles upstream. So my other distance is going to be 20 here for upstream. So I'm going to replace my distance upstream with 20. Okay, after I do that, let's see what else we've got. If the speed of their boat is 8 miles an hour, so that tells me that whenever I see a B for boat, I can replace it with 8. Okay? So that's starting to look a little bit better. And at this point, let's mess around with this equation. Let's use some distribution and see what we get. So we have 8t plus wt equals 60. And if we distribute over here, we've got 8t minus wt equals 20.
If the times aren't the same, why did we even keep them in?
Because it wouldn't be the distance.
Yeah, you have to, the equation is distance equals rate times time. So even if the times are the same, you still need it in there as part of the equation.
Does this equation
We
still
actually
equal
do
each other if they
Wait,
did
what does
them?
W
Right.
stand for?
Yeah, speed of the water. Okay. So if that's the case, now we have two equations. How many variables? Two variables. So
But
now what we have to do is system of equations. Notice here,
Oh, yeah.
if I add these two, this disappears. Okay? So I get my two equations. I use substitution or elimination. In this case, I didn't have to use any. These canceled out. So 16t is 80. My time is 5 hours. So it takes me 5 hours to go upriver 20 miles or downriver 60 miles. But the key thing, I need to find out what in the world I was supposed to find for this. It says, what was the speed of the current and what was the time? Well, we found the time. How fast is the current going?
4.
4. How in the world did you get 4?
I worked it out.
I worked it out too.
You,
Yeah,
put
you
it
just-
into the equation.
You just put 5 in here for t and solve for w. Okay, and you find out that your water speed is 4 miles an hour. Okay? That's it for these.
Sounds good to me.
You use those two equations, b plus w times t equals d, b minus w times t equals d. Plug the numbers in. Okay, guys, all you're doing is writing the equations, plugging the numbers in that you know, and then using substitution or elimination like you do here in order to eliminate one of the variables and then plug it in to find the other one. The key thing about these isn't the difficulty of the problem, because I think you're finding out these aren't really that hard. The difficulty is remembering to give me the answer that the book is asking for. Just because you find t doesn't mean that's what you were looking for. It may just mean part of the journey to get to what you're looking for. So that's a key thing, is make sure you take care of that. Okay.